Welcome to the EEE360 video for lab number 12, alternator power. For this lab, we'll be using the following components. We'll be using the AC power supply, the DC machine, the synchronous generator, the AC ammeter, AC voltmeter, synchronizing module, 3-phase watt meters, the DC ammeter, as well as the handheld tachometer. And now the TAG Chang is ready to make the connections for us. First, we're going to set up our DC machine. We're going to go from our fixed DC power supply to one side of our armature winding. Now we're going to connect power to our shunt winding. We need to make this connection in the middle to make sure we power the entire shunt winding. Now we're going to connect the neutral of our power supply to the other side of our armature winding. We're also going to connect the neutral of our power supply to the other side of our shunt winding. And now we have the DC motor properly set up. Let's set up the DC excitation for our synchronous generator. We're going to go from our adjustable DC power supply through a DC ammeter. From the DC ammeter, we're going to connect to the rotor windings on our generator. We're going to connect the other side of our rotor winding to the neutral of our variable DC power supply. Now that we have our input connected, let's connect the output of our generator. We're first going to start by shorting one side of the stator windings. And this ensures our proper Y connection by shorting this side. We also want to double check the line-to-line voltage of our generated voltage from our generator. So we're going to check the line-to-line voltage between phase A and phase B. Now we're going to connect the output of our generator to the input of the 3-phase watt meter. First, we're going to connect A phase through the AC ammeter. We're going to connect the AC ammeter to the A phase input on our 3-phase watt meter. Now we'll connect the B phase output of our synchronous generator to the B phase input of our 3-phase watt meter. We'll also connect our C phase output to the C phase input on our 3-phase watt meter. Now we're ready to connect the output of our 3-phase watt meter to the generator side of the synchronizing module. First we'll connect A phase. Now we'll connect our B phase output to the B phase generator side. And we'll also connect the C phase output to the C phase of the synchronizing module, the generator side. Finally, we're going to connect our fixed AC power supply to the grid side of our synchronizing module. We're going to also connect B phase. And finally, we'll connect C phase as well. And now our connections have been properly made. And now we're ready to energize our circuit. First, we'll turn on the power supply. And now we're going to adjust the speed of our DC motor to ensure that we are at 1800 RPMs. Now that we've set 1800 RPMs, we're going to start supplying DC excitation to our generator. We're going to close the switch. And we're going to increase the DC excitation until our generated voltage is 208 volts line to line. Now that we're at 208 volts, we're going to change the speed of our motor so those lights blink a little slower. Remember, we only want to close that synchronizing switch when the lights are fully off. So now that the lights are off, we're going to close the switch, and now we have our generator connected to the grid. We're going to adjust the speed of the DC motor as well as the DC excitation to our generator until both watt meters read 0. When this happens, we have our generators just floating on the line. Now that we have that set, let's take a close look at all our measurements. Here's our DC current excitation. This reading is 0.61 amps. And here we can see that our generator is supplying approximately 0.04 amps. And here we can see that our generator voltage is approximately 212 volts line to line. And now, students, it is your chance to do this and other experiments with the alternator as outlined in your laboratory manual.